This lesson is on simplifying algebraic expressions. We often want our expressions to be as simple as possible. So we can actually use some algebraic properties to simplify our expressions so that they are as simple as possible but still equivalent. Let's take a look at some of these properties. The first one is commutativity. So the commutative property, you can think of the word commute. You're switching order, so you're actually switching the order of, say, either the multiplication or the addition. So a times b gives us b times a. You can multiply in any order. 2 times 3 is 3 times 2. Also, a plus b is b plus a is another version of commutativity. So an example in something that relates closer to the examples in this unit, say you had x times negative 3 times y. So that's not quite as simple as possible. It's got brackets, it's kind of awkward looking. So we always like to write our letters at the end of our term, our little multiplication cluster, and the numbers at the front. So we're going to use the commutative property to rewrite x and negative 3 as negative 3x. Well, the y follows. And that's as simple as possible. The next one is associativity. So the associative property, you can think of associating different terms in different ways. So let's say you had a times b times c. You could associate b and c first, meaning multiply those first and then times a. Or you could associate a and b first. You could do those first and then multiply by c. It really doesn't matter in the case of multiplication, or for that matter, addition. However, if you tried these same examples and input numbers and replace these with either subtraction or division, neither of these properties would work. Let's take a look at an associative property example. So say you had 5 times negative 2x, and that was part of your simplification. And you wanted to write this a little nicer. Well, we don't want these clunky brackets here, so let's switch them because we can't go negative 2 times x. We want to actually do 5 times negative 2, which has a value. 5 times negative 2 gives us negative 10. That gives us negative 10x, and that's simpler form. Letters at the end, numbers at the beginning. The next property you can use is the distributive property. This takes multiplication over addition. So say you had a times b plus c. You had a groups of b and c. Therefore, you had a groups of b and a groups of c. The beauty of this is you can rewrite and get rid of your brackets at any stage of your simplification using the distributive property. It's a very nice property to use at anytime you want to get rid of a clunky bracket. So a lot of times when you're simplifying, you can't actually combine the things in your bracket. Often they're letters and numbers and they don't mix. So we need the distributive property. Here's an example. Negative 2 times x minus 3. The x and the negative 3 cannot be combined. Therefore, we can use the distributive property to remove the brackets and hopefully take it to a simpler form. So here we're actually going negative 2 times x and then adding negative 2 times negative 3. That's a preliminary step. You don't have to write that. So you actually have negative 2x and then negative 2 times negative 3. Negative 2 times x, negative 2 times negative 3, which is positive 6. And there you have it. Now sometimes when you do that, you still end up with a further simplification that has to do with combining like terms. Like terms are terms that have the same endings, variable endings. And what you can do with the same variable endings is you can add the numerical coefficients together. So take an example. Say you had 5x squared y minus x squared y plus x squared y squared. So determine how many terms you have. You have 3 terms: positive 5 x squared y, negative x squared y, and positive x squared y. The numerical coefficients are the numbers multiplied, the numerical portions. The variable endings are the variable portions. So you can see that the first two have the same ending, x squared y. The last one does not. Therefore, we can combine the 5x squared y's minus 1x squared y as one term, but the x squared y squared has to stay, giving us 4x squared y plus x squared y squared. Let's take a look at some examples of simplifying expressions. We may remind ourselves of the properties. You can also pause the video and try these on your own, and then come back and check if you've got them. All right. Simplify each expression. Number 1, you've got 3/4 times negative 16x. So we've got this clunky bracket that we can reassociate to giving us 3/4 times negative 16 times x. Now, 16 is over 1. If you have troubles with this portion, see the video on operating with fractions. So we can simplify. 16 divided by 4 gives us 4, and so that's the same as 3 times negative 4, which is negative 12x. You could also go 3 times 16 and divide that by 4, and you'll get 12 as well. Next one, number 2. You've got the same endings here, so that's using the like terms property. So we've got negative 1x squared plus 3x squared minus 7x squared, giving us negative 1 plus 3 is 2, minus 5, or minus 7 equals negative 5x squared, and that is simpler form right there. Next, number 3, we've got brackets. Now, to get rid of these brackets, we can use the distributive property first. So the 4x stays, and then we've got x times 2x, and then x times 3. Now within here, you'll notice you'll have to use a little bit of commutative property to rewrite this as 2x times x, which is actually x squared. I'll just write it as x squared plus 3x. Now you'll notice you still have some like terms here as well. The 4x and the 3x can be combined to give 7x plus 2x squared. Now this is correct, but also you could answer it as 2x squared plus 7x. This is actually preferred. It's a little more standardized because it's in decreasing exponential order. Some more examples here. Number 4, we've also got the distributive property. We need to get rid of this bracket. So let's get rid of the bracket. We have a negative 1 up front, and we're distributing that negative 1 to all 3 of our terms. So we're going negative 1 times 3x is negative 3x. Negative 1 times negative 7y is positive 7y. Negative 1 times positive 1 is negative 1. Now, we have no like terms, so that is complete. Number 5. We've got a whole bunch of multiplication here. We don't actually have any addition or subtraction, you'll notice, because of these brackets. These brackets imply little multiplication symbols. Therefore, we can reassociate, we can commute, and bring all the numbers up front, giving us -3 times -4 times -2, and the letters at the back times x, which gives us negative times negative times negative is a negative. 3 times 4, 12 times 2 is 24. X times x is x squared. And we're done. Number 6. Let's take the distributive property again. Because of these brackets, we need to get rid of those brackets. So you've got -3 times x and -3 times +2. Remember to take that negative and keep it with a 3. The 5 is separate. This is a +5. -3 times x gives us -3x. -3 times +2 gives us -6. You'll notice we've got some like terms here. Let's put those together and keep our highest variable first, so -3x, and then 5 minus 6 is -1.